Hi everyone, welcome to today's tutorial on Best Science Brain YouTube. Today we are going to look at experiment on refraction of light using rectangular prism. As you can see on the screen, we have the rectangular block A, B, D, and C. Okay, we also have the incident ray. The incident ray is QU on the face AB, and then this is the angle of incidence. Then the number drawn, that number is RQT. Then we have the angle of refraction beneath the angle of incidence, the R, small r. Then when we go down, we see a displacement EF being measured. We now see pin P1 and P2 on the incident ray. When we come down, we have pin P3 and P4. That is such pins, and this is the position of our eye there. Then looking at the triangular block, we have BC. That BC is the width. W, the width of the rectangular block, not triangular, sorry, rectangular block. Now, they go into the question. We are told you are provided with rectangular block, a drawing board, drawing sheets, 4 optical pins, and other necessary materials. Use the diagram above as a guide to perform the experiment. Number 1, measure and record the width of the block. The width is our W, that's the length BC. We go back to the question. Number 2 says, draw the outline A, B, C, D of the block on a drawing sheet. Mark a point Q on AB such that AQ is 1.5 centimeter. Draw the number RQT as shown in the diagram above. Let's go to the diagram. We're going to draw the outline, trace the outline A, B, come down, C, and D of the block. After I've done that, we'll draw the number RQT, that's a straight line. And then mark at angle 10 degrees here. That is angle of incidence using a protractor. Okay, let's go back to the question. We are done. Number 3, draw a line UQ marking angle I 10 degrees with the number RQT. Then IV says insert pin P1 and P2 on the line UQ. The UQ, the incident ray. Look through the side DC of the block and insert 2 other pins, P3 and P4, and extend it to meet DC at E. Number 5, remove the block and mark the position P3 and P4. Draw a straight line joining P3 and P4 and extend it to meet DC at E. Number 6, produce a line UQ to meet DC at point F. Draw a straight line EQ. VII says measure and record angle R, refraction, the length EFD, and evaluate tan I, tan R, and V. V is tan I minus tan R. Then VII say using different outlines of the block, repeat the experiment using incidence 20 degree, 30 degree, 40, and 50. And in each case, measure and record our angle R, our D, and evaluate tan I, tan R, and V. So we're about to start the experiment. we'll go through the diagram again. This is the prism, rectangular prism. The normal is RQT. Normal is a straight line. So mark on the prism, RQT. After I draw a normal, we're going to draw a line, QU, which is the incident ray. And then we're going to start with angle I being 10 degrees using the protractor. After we've done that, we're going to place two pins, P1 and P2, on the incident ray. When we have done that, we'll now go to the face DC, and then we view the image, the eye position, view the image from the prism, and try to get the word, use the search pin to get the image of the pin in a straight line. We should know that no matter where you view the image on this base DC, no matter the position you stay to view the image, you see the images. But we're looking at a position whereby the image we are seeing as viewed through DC will be in a straight line. So when we're able to get that position, we now place our search pin P3 and P4 and then complete the construction. And then measure angle R and measure angle I and measure the displacement, which is EF. So we are now about to start the experiment. This is the rectangular glass prism we have here. We are asked to measure the thickness of the block. So we have to measure the thickness of the block using the centimeter end of the meter rule. So the block gives me 6.4 centimeter. 6.4 centimeter. So the thickness of the block is 6.4 cm. We'll write W as 6.40 centimeter. So having done that, we'll now trace the arc line as instructed. So we have the arc line of the block A, B, D, and C. So we have a protractor. We will now measure out the first angle of incidence is angle 10 degree. So we have to get 10 degree. Okay. We make sure the baseline of the protractor covers the line AB. Then here is 90. The 90 is our normal. Then this is normal here, 90 degrees. Then the 10 degree is 90 to 80. That will get 10. Because 90 minus 80 is 10 degrees. So we are now going to draw a straight line for our normal. So that's the normal. Then we'll now draw the angle of incidence, which is our 10 degree. Okay. So having done that, this is our Q, and this place is our R. Oh, sorry, this place is our U according to the diagram. U, QU, the incidence ray. This is the angle here is our angle of incidence. So our I for this experiment is 10 degrees. Then we now put the pin on the incidence ray. We put one here. We leave enough gap, a gap of a distance of about not less than 4 cm for accuracy before we put the second pin. Second pin will now be around here. distance of not less than 4 cm. They should not be too close. So when we are done that, we now return the prism. We make sure that the pins are on a straight line. Return the prism and then view the image from this side, which is DC. So the pins, we're going to get the image of the pin and observe from the face DC. So here we are. So we are joining the points P3 and P4 with a straight line, that the search pins. Then we remove this. This place is our P1. This other place is our P2. What then do we do? From the construction, we now join, we extend the incident ray with a straight line. The incident ray is extended. That is our QU extended, so that we can get the displacement. Having done that, we also join this point. We join Q to this point. We join Q to this point. So this point is called E from our illustration. This is E, while this point is F. Then the angle here, made here, is the angle of refraction. That is, this here is our R. So we're going to measure the angles now. So we're going to measure the angle of refraction here. This is the normal going straight. So we'll make sure that the base of protractor covers the normal, covers A, B. The baseline of protractor covers AB. AB is the line, the first side of the rectangular prism. Then the normal, you can see that the line of the normal is passing through 90 degrees. So this is the line for refraction. Read of the line here, the angle here. Here is 90. Here is 8. This is 90, 85. So 90 minus 85 gives us 5 degrees. So the angle of refraction is 5 degrees for the 10-degree incidence. They will read off the distance DC. The distance DC here will be obtained by measuring DC, the displacement from here to there. When we measure the distance DC, we're going to get the displacement as at about 0. This is 1, 0.8 cm. So our EF, which is D, is 0.70 centimeter. So we're going back to the second experiment. Having done the first one, we still trace the outline of the prism. Draw the outline of the prism. We can label it. A, B, C, and D. That's the outline. So for the question, they say draw outline A, B, C, D of the block on a drawing sheet. Mark a point Q on AB. Point Q on AB. And that point Q is The AQ is 1.5 cm. So we'll go to the AB and mark out 1.5, which should be here. So this place is our AQ. So at this point, we're going to draw our normal. Put our protractor. Make sure that the baseline of protractor is covering AB. And then we'll draw our normal. This is the base, normal here. So we'll draw a normal, and then we're going to mark out angle. What angle we're marking out? Angle 20 degrees. Here is 90. So 90 minus 70 is 20. So here should be 20 degrees. So we're going to do that. So we'll draw our normal at this point. A straight line making angle 90. They will now bring out angle 20 with the angle of incidence. Okay, so having done that, we'll now place the incident pin, which is our P1 and P2. P1 will give enough gap. I said about 4 cm before placing P2. So the two pins should be about 4 cm apart, the P1 and P2 pins. So having done that, we'll make sure they're on a straight line. Then we'll return the prism and then view the image from the other side of the radar from this face, DC. So I have the image. We'll open the image. So having obtained the image, we'll now draw a straight line to pass through P3 and P4. Then we'll move the incident ray straight to cross the face DC. Then we'll draw a straight line from the midpoint there. We'll draw a straight line to meet this point E. Here is E. We're now going to measure the angle of refraction, which should be here. We'll can bring the normal down. We can measure the angle of refraction here. This is the angle of refraction. And then measure the displacement, which is D from here, because this place is F for the diagram. So we're going to measure the angle of refraction. This is our normal, this straight line. So we make sure that the base line of the protractor covers our face AB, the line AB, and then make sure the 90 degree on the protractor is lying on the normal. Look at the 90 degree on the normal line. Then this line here, this line represents the line of refraction. You read it off. Here is 90, and this point is 90. Here is around 82. So 90 minus 82 gives us 8 degrees. So the angle of refraction here for 20 degrees is 8 degrees angle. They will measure the displacement from here to there. The displacement in centimeter is 1.5 centimeter. So our displacement is 1.5 centimeter. If you observe the trend, we see that when the angle of incidence was 10 degrees, our refraction was 5 degrees. Here, refraction is 8 degrees. The display is 0.7 here. Here is 1.5. So it's increasing as we go on. So go to the third experiment with the incident angle at 30 degrees. We have done 10 and 12. Go to the third one, 30 degrees. So we trace the outline of the rectangular block again once more. And from the instruction on the first page, here is our A, here is our B, here is our C, and here is our D. On the first page, we are told to measure AQ. This distance AQ should be 1.5 centimeter. So we take our 30 centimeter rule and measure out or mark out 1.5 cm, that from here to there. When we have done that, we now get our normal, making sure, okay, we cover the baseline AB. Normal is 90 degrees, which should be here. This is 90. And then the angle of incidence now is 30 degrees. This is 90. That will be at 60 because 90 minus 60 gives us 30 degrees. You can count it. 90 to 80 is 10. 8 to 70 is 20. 70 to 60 is 30. When we have done that, we can now draw our normal. The straight line at 90, we have our normal drawn out. Then we'll now mark out angle of incidence of 30 degrees. Having done that, we'll now put our optical pins P1 and then P2, making sure we space about 4 centimeter gap. We give about 4 cm gap, not less than 4 for accuracy. We have P1, we have P2, making sure they are vertical, they are erect. Then we return back the prism and view the image of the prism from the face DC. So we are now locating the image, making sure down a straight line. So that's okay. So the image, the line, they did the search pins P3 and P4 that have been joined by a straight line, and then the incident tree have been produced straight down to the face, beyond the face DC, and then we join a straight line from here, this point, which is E, to the midpoint there. Then let's measure the angle of refraction, which is the angle that is here, keeping the base or the baseline of the prism on line AB, and this is 90 degrees as you can see it here. Then we'll read off this angle. This is 90, here is 80, that is 10, here is 5, 80, 10, 80 minus 10, 90 minus 80 is 10, and here is 5, that is 15 degrees. So angle of refraction when I is 30 is 15 degrees. We now measure the distance DC. The distance DC, that is from here, DEF, sorry, that is our small d, will now be measured. The value is around 1.9. So our small d is 1.9 cm. So we're going to the fourth experiment where the angle of incidence is now 40 degrees. The outline have been traced already, and from this Q from here to this point is 1.5. So we'll mark out our normal, that is 90 degrees. Normal, here is 90 degrees. We still measure at 40 degrees. 90 to 50 is 40. Because 90 minus 50 is 40. That is, if we count it, 90 to 80 is 10, to 70 is 20, to 60 is 30, then to 50 is 40 degrees. So here is 40 degrees. So having done that, we now join the point. So here is my normal. Draw the normal and bring the line down. Then this place is 40 degrees. This point is 40. This then 3, or is then angle is 40 degrees. Having done that, we'll now put our pins P1 and P2. Put P1 on the line, and then to place P2, we have to give a distance. Is a precaution. So even though you're not saying the equation, you have to space it. Give a distance of about 4 to 5 cm before you place P2. So our P2 comes here. Okay, about 4 cm distance. Make sure the pins are straight. We bring back the rectangular block and then view the image of the pins through DC. How do you know that the image is in a straight line? We view it in a way whereby we see only one of the pins. The other one will be covering the other pin. So if this is P1, P1 will be covering P2, only be seeing only one of the pins. That one we know is a straight line, if they are in a straight line. Trying to locate the image, making sure this one, the first pin, blocks the image of the 2 pins, while the second one blocks everything totally. So that we are looking at the second pin, I will not be seeing anything at all. It will be blocking every other, it will block the first pin and also block the images. So that means that is when you know you have a straight line situation. So having done that, we remove the pins and then join the points to the face DC. Join the points. This point is P3, this point is P4. Then, having done that, we extend the incident ray. This point is our E. This point is our F. There we draw a straight line from the midpoint where you have the emergent ray. So this is the refracted ray, the incident ray, and then this is the emergent ray, while this is the normal. So we're about to measure the angle of refraction for incident angle of 50 degrees. The angle of refraction now is going to be from here, this is the normal, then this is the refracted ray. This is 10, this is 15, this is 10, this is 15, is about 16 degrees. So angle of refraction is 16 degrees in this case. Then our displacement with the distance measured from E to F. Our displacement in centimeter is giving us around 3 point, let me get it right, around 3.5 centimeter. So we are on the 5th angle, incidence of 50 degrees. Already the outline have been traced, A, B, C, D. So and from A to Q is 1.5. So let's mark out our angle 90 being the normal. Then angle 50 is going to be from 90 to 40. For 90 minus 40 is 50 degrees. So we'll have 50 here, over there. So having done that, we'll draw our normal. Bring the line down. Then draw angle, line incident angle of 50. You can as well bring it down, since you see do it later on. Bring it down. So having done that, we'll now place our pins P1 and P2, leaving enough distance that is not less than 4 cm. Enough distance or space between them. Then we'll bring back the prism and then view the image through the face DC. So we'll look for the search pin and then view the images. Image or the images of the pins P1, P2. So we'll have it there. All right. So we're about to measure the angle of refraction. This is the protractor on the baseline of AB. The baseline protractor covering AB. Then this is our normal 90-degree line, the 90-degree. They will measure the angle here. The angle we're seeing here, this is 10 degree. 90 minus 80, that is 10. 11, 12 is between 12 and 13, that is 12.5. So angle of refraction is 12.5. Then the displacement between E and F, having done the construction, EF when measured is giving us this is 0, this is probably 5.1 cm. So our displacement is 5.1 centimeter. So here we're looking at the first experiment where I is 10 degree, and we observe that there's a mistake here made by us. The distance from A to Q is supposed to be maintained at 1.5, but we did not measure accurately, we just estimated the distance. So we're going to repeat this one and keep A to Q as 1.5 as we did in the other experiments, so that I don't make mistakes. So I have to correct this mistake here. From here to this point should be 1.5 cm according to the equation. So this is the 10-degree incidence, and we got at our refraction as 5 degree. The refraction is the angle here, measured at 5 degree. Then the displacement EF measured as 0.6 centimeter. So if you compare it to the first one we did for 10 degree, you have I as 10, R as 5, the same 5 as this 1, and then this displacement is 0.7, 0.6. So you see that the results are almost for 10 degree, whether it's almost the same thing. So we have to obey the instruction of keeping from A to Q at 1.5 cm, which is neglected, we remember that. But despite the fact that we obey the instruction, we're still getting almost comparatively the same result as the first experiment. So we're going to now compile all the data together in the experiment. So these are the table of results we have. The compilation result, the width of the prism we got at 6.40 cm. Then this is the angle of incidence. We have 10, 20, 30, 40, and 50 as we did in the experiment. The angle of refraction measured 5 for 10 degree, 8 for 20 degree, 15 for 30 degree, 16 for 40 degree, and then 12.5 for 50 degree. The lateral displacement to measure D, which is equivalent to EF, 1.6 cm for 10 degree, 1.5 for cm when the angle is incidence is 20 degree, 1.98 for 30 degree incidence, 3.5 for 4 degree incidence, and 5.1 for 50 degree incidence. Then we got tan I, that is tan of angle of incidence. Tan of 10 is 0.1763, tan 20 0.640, tan 30 0.5774, tan 40 0.8391. They will also got the tan of angle of refraction, as we are told to do it we are told to do that in the equation. Then tan 5 gives us 0.8749, tan 8 gives us 1405, tan 30 0.2679, tan 40 0.2867, and tan 50 0.2217. Sorry, this one is tan, there's a mistake here. Tan 5 is 0.86749, this is tan of hour. Tan 8 0.1405, tan 15 0.2679, tan 16 0.2867, then tan 12.5 0.2217. The column is for tan of angle refraction. They were asked to find evaluate V. V is tan incidence minus tan of refraction. That is this value here minus this value. 0.1763 minus 0.8749 gives us 0.0881. 0.3640 minus 0.1405 gives us 0.2235. 0.5774 minus 0.2679 gives us 0.3039. Then 0.8391 minus 0.2867 gives us 0.5524. 1.192 minus 0.2217 gives us 0.9703. We'll now go to the graph plotting. So we have our graph. We have to plot D in cm against V in V